In previous 3 video, we discussed about asymptotic notation by definition, and we discussed about big O, omega and theta. Omega is nothing but making left hand side greater than right hand side somehow by using any constant value c, and by taking any n value n naught, and that n naught value will always the lower limit, that from that value all the value which is greater than n naught will follow or hold good for that condition. And also we will see about big O notation, that making right hand side somehow greater than left hand side by using c, and also there we see n naught. Next we see about theta notation. Theta notation is nothing but it is equal. Theta means equal. If the both function are equal, then we can write directly that theta is hold good. And in other word, we can write if omega and big O hold true for the same function for different c, and for we need to choose one n naught value, that n naught value will be greater than both, greatest of both, that is n naught, that is omega and theta, omega and big O, then that is theta notation. In this lecture we will see graphical representation of asymptotic notation. Actually asymptotic notation not means mathematically equal, it is actually approximation. Mathematically equal is another thing, that we can't write in mathematics n naught plus 5 equal to n naught, that is not possible. But if we go for asymptotic notation, we can write by using theta, omega, anything. This is in previous video we see that this is theta of n, we can write it, this is asymptotic equal. Now we will see in this lecture graphical representation of asymptotic notation, big O and theta. Let's take this is in this axis f g of n and f of n will hold, and in this axis there will be input, that is n naught. Okay. Now if there is a function f and there is another function this is f of n, and this is g of n. Look, we are not able to say that f of n is greater than g of n or g of n is greater than f of n, because there sometimes f of n is greater than g of n, and sometimes g of n is greater than f of n, here f of n is greater than g of n. Okay. Now we need to find some point, that g of n should always greater than f of n from this point. Okay, this is g of n and this is f of n. Okay, and this, if we are able to find some point, from that point if we go beyond that point, and then g of n is always greater than f of n by using some constant c, then this is nothing but omega notation. This is the function of or graphical representation of f of n equal to big omega of g of n. That is, f of n is always lesser than equal to some constant g of n, and for all n, n is greater than equal to n naught. That is, from n naught onwards, if we go more value increase, and n naught is lower limit. From n naught, if we go any value, that value, and using c constant, the f of n is always lesser than equal to g of n from this point. This is nothing but this is n naught. That is, from n naught, all the value greater than n naught or n naught, g of n is greater than or equal to f of n. Okay, this is the big O notation. Okay, now we will see omega notation. Okay, f of n and g of n. Here 1 2 3 4. Okay, dot 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 4. This is n naught. Now this is f of n and this is g of n. Now we need to find some c from and also n naught by using c constant and from n naught. The value of f of n, is greater than equal to g of n. That is, this is g of n and f of n. That from, if we take n naught here also 4 or any n naught value, this is nothing but n naught value. From n naught, all the value greater than n naught, this condition will hold true, that using constant c and all the value which is greater than equal to n naught, f of n will always greater than equal to g of n, or in another word we can say that f of n is greater than equal to g of n by using constant c and all the value greater than or equal to n naught. F of n equal to omega of g of n. Okay, then f of n is greater than equal to constant c dot g of n for all the n value, where n is greater than equal to n naught. Okay, from this is nothing but n naught and this constant. Okay, and this is input, number of input in the algorithm. Okay, now now we will see another that is another asymptotic notation, that is theta notation. We will see theta notation. This is from red color create g of n, and from black f of n. Okay, now we need to prove that we need to find some constant value c1 and c2, and also n naught value. From that n naught, f of n is theta of g of n. Now from n naught, this is nothing but n naught. Here this is g of n from red color. Here g of n is lesser than f of n, and here f of n is lesser than g of n. We are not able to find the from 1 to 4. Here only example, from 1 to 4, from 1 to 4 or from 1 to 4, we are not able to say that g of n is greater than f of n, or f of n is greater than g of n, or which relation is hold between g of n and f of n. But from 4 onwards, we use two constant value, that is c1 dot g of n and c2 dot g of n by using two constant, that is f of c2 dot g of n will always greater than f of n. This is nothing but f of n. F of n from black color, f of n. This f of n is always greater than equal to g of n when we take c1 as a constant, and f of n is always lesser than equal to g of n if we take constant value c2. This is the graphical representation of theta notation for n naught. Here number of input. Okay, this can be written in question form. F of n equal to theta of g of n. For first, f of n should be greater than equal to c1 dot g of n. This is nothing but omega. And second, f of n is lesser than equal to c2 dot g of n. This is nothing but big omega. Okay, for constant c1 and c2 and sum n naught. Here n naught, we, for example, I am taking n naught as 4. N naught can be any value. From that, all the value greater than n naught or n naught, This condition will hold true by using constant value C1 and C2. If you have any confusion, you can write on comment box. This is the graphical representation of big omega, omega and theta notation. Thank you.